Hello everyone, welcome back to Coders Project. Today we're going to be solving the convert sorted array to binary search tree problem on LeetCode. So I'm going to break this down step by step so you can ace it confidently. This is a great problem to sharpen your recursion and binary search tree skills. So let's get started. Go ahead and pause the video and take a quick look at the question. Alright, so what the problem is asking us to do is we are given a sorted array of integers. We need to convert it to a height balanced binary search tree. What does it mean? Basically, a binary search tree follows a specific structure. The left subtree nodes are smaller than the root, and the right subtree nodes are the larger ones compared to the root. And the height balanced means that the depth of the left and right subtrees of every node must differ by at most one. Our goal is to basically write a function that takes a sorted array and which will build a tree which will satisfy the left and right subtree nodes condition. The key idea here is to leverage the sorted property of the array to place the middle element as the root. This is going to give us a balance subtree automatically. Okay. So what we're first going to do is we're going to identify the middle element of the array that is going to become our root. And then we're going to recursively apply the same logic to the left and right halves and then construct the left and right subtrees. So let's quickly take a look at the class tree node which they have provided. It has a value left and a right node. So let's get started. The first thing what I'm going to do is I'm going to eliminate the base case. If the array is empty, then we can just return none because there's nothing to add to the tree. So if not our array, which is nums, we can return none. Now we can go ahead and find the middle element. This will be our root node for our current subtree. So we can select mid as length of nums by 2. And then our root is going to be our tree node of nums of mid. Alright, so we're calculating the middle index from our array, and then we're going to create a new tree node with the value of the middle element. Now we'll have to recursively build the subtrees. We're going to compare the left half of the array first, and then we're going to proceed with the right half. So root.left is equal to self, and then I'm going to recursively call this function of nums from the leftmost until our mid. Similarly, we're going to check for the right subtree now. Root.right, it's going to be from our mid plus 1 till our nth element. So this will ensure we are only parsing the relevant portions of the array. And then finally, we'll return the root node for the subtree, which is now linked to its left and right subtrees. And that's it. The recursion handles the rest by repeatedly dividing the array until all the elements are placed in the tree. Talking about the time complexity, each recursive call splits the array into two halves, so the depth is big O of log n, and at each level we are processing the entire array once to find the middle, so that's going to take big O of n. Combining these, our overall time complexity is big O of n because we visit every element of the array exactly once. Let's go ahead and run the code. Alright, all our test cases are passed, and here is a concise yet a powerful way to convert a sorted array into height balanced binary search tree. Recursion does all the heavy lifting here, and understanding how it breaks the problem into smaller chunks is the key takeaway from this video. If you enjoyed the walkthrough, don't forget to like, subscribe, and hit the bell icon for notifications. Let me know in the comments which LeetCode problem you'd like me to tackle next. Thank you for watching. See you in the next one.